probably most of you know, I'm Fiona Hara, I'm the Secretary of the Society. I'm actually really indebted to Dr. Gabby Bodar, who put together the programme for the colloquium today and has really done all the organisation along with our 3 speakers that we're going to be hearing from this afternoon. What will happen is that the three speakers will give their talks. There should be time at the end of each talk just for maybe 1 question, but there will be time before tea for some more questions if you have questions sort of to all 3 of them. And then we'll break for tea at 3:45, and then we will start again about 4:15 when Gabby will give a short talk, and then there'll be an opportunity for a round table and a Q&A session. So that's really the plan for the afternoon. To start with, it gives me great pleasure to welcome Dr. Charlotte Tupman, and she's going to be speaking on analysing inscriptions at scale through images using machine learning for the study of letter cutting practices. So thank you, Charlotte.
Thank you very much for the invitation to come and talk today. I've been asked to talk about a case study where we've been using machine learning to experiment with analysing inscriptions, images of inscriptions in fact, to try to learn a little more about layout practices. Now, my work was focused more on the Roman world. I hope you'll forgive me for that. I'm mainly going to be looking at Latin inscriptions here, but given that this technique can apply much more widely, we hope, I hope that it'll be of some interest to you today. We have some evidence for how inscriptions were planned in the ancient world. Not as much as we'd like, is the truth of it, but we have some things that are left that enable us to understand a little bit about the processes of planning an inscription. I don't know whether you've noticed guidelines, for instance, sometimes at the top and bottom of letters in inscriptions. You also find vertical guidelines, although that's a bit less common. Sometimes we also have indications that letters were painted before being inscribed or marked out in charcoal. And of course we can use what are often known as stonecutters' errors or letter cutters' errors, but which are not necessarily their errors, to tell us a little bit more about the extent to which inscriptions were planned out before they were carved. We also have some quite rare but very interesting stones such as this one. This is a plaque which has an epitaph on it, but on the reverse we have a rough draft of that text in cursive lettering, which again can give us some idea of the fact that somebody involved in the process was thinking about how to space out the inscription before they carved it. Most of the work that's been done so far on this has quite understandably been focused on in-person measurement of specific stones, obviously, and Richard Grousby, whom some of you may have known, was involved in a series of studies of particular inscriptions, looking at how they were spaced out, looking at the ratios between letter heights and widths and between lines to try and work out what kind of module was used, so what measurements were used in order to space out the letters in particular inscriptions. And he came to some really interesting conclusions about the extent to which that was done. And it's well worth having a look at his work if you're interested in these subjects. And he actually used it to recut one of the inscriptions that he was interested in, because he himself was a letter cutter. And so he worked from the original stone, sort of planning back, looking at how it was created, and then with the area of the stone that was now missing through damage, he then created a new version of that, which he believed was somewhat more accurate than the previous reconstruction. There has been other work done in this general area, things like looking at how or whether we can identify particular people who might have carved the same inscriptions. So Stephen Tracy's work obviously is important in this regard. He also used pattern recognition to examine particular letters and look at how similar they were across different inscriptions. And we have other techniques that we can use, again, for sort of in-person measurement, which can tell us a little bit more about the contours of the stone and the surface of the stone. So 3D techniques such as photogrammetry and scanning and reflective transformance imaging as well. And we can use all of these to tell us a little bit more about this question. But today I'd like to talk to you about how we might go about analysing layouts at scale. One of the reasons why this would be worth doing, I think, is to identify the sort of patterns that exist in designing and creating inscriptions. We also can use that to help us to date inscriptions more accurately and also locate them. We can possibly also use that to reconstruct missing parts of text, and we'll come back to that in a moment. And of course, the sort of the ideal world goal of this would be to think about whether or not we can identify individual workshops or the work of particular letter cutters. Now, I'm certainly not the only person working on these things. We have one of our speakers today who has two incredible projects, both of which are addressing questions, well, one of which is addressing questions about reconstructing parts of text that are no longer there, and the other of which does that, plus gives us information about dating and location. And so what I'm trying to do is look at an image-based approach to this, so analysing the visual aspects of inscriptions, which can then sit alongside the more text-based approaches. So the first thing we need to do, if we want to analyse inscriptions at scale, given that we have tens or hundreds of thousands of images in inscriptions, the first thing we need to do if we're doing this computationally is we need to ensure that the computer understands where in the image the text is. Now that's a really basic thing, but it's actually really hard to do when it comes to inscriptions, as we'll see. And we wanted to conduct a sort of experimental project, a pilot project, to see whether or not we could get to that first stage. And so through a project that was kindly funded by IDSI, the Institute for Data Science and Artificial Intelligence in Exeter, we used some of the images that were available in the Heidelberg database to start addressing this first step. And I collaborated with two computer scientists, Jack Christmas and Dimitri Kangin, for this project. We used something called a scene text detector, which uses a neural network to look for word and line level text within images. Now, it was trained on data sets like the one that you see above me. Am I actually standing in the way of your view? Please tell me. Maybe I'm sufficiently short that you can still see. So we okay, oh, thank you. We use a scene text detector called EAST, which is called Efficient and Accurate Scene Text Detector, which I thought was a very optimistic, but in fact quite accurate word for that, name for that. And its training data was of the type that you can see. So street scenes, it was looking at things like adverts, bus signs, and so on. So we wanted to use the detector and then give it images of inscriptions and see if we could train it to see the text within these images of the inscriptions. So supplementing that original training data. And the idea behind this is we wanted it to produce a set of bounding boxes or boundary boxes which showed exactly where the text was in each image. And in order to do that, we followed a sort of iterative workflow. So we selected some images from the EDH, the Heidelberg database, and we deliberately selected images that had all sorts of problems, ranging right through to images that were very clear, so where the text was very legible and so forth. We then asked it to try to recognize the text based on the data set, the training data set that it had. We selected the image where it had accurately detected the text, and then removed any false negative detections, so areas of text that hadn't been correctly identified as text, and then fed those back and retrained the model. So it was very much an iterative process of continuing to train the model and seeing over the months how it improved, or whether it improved. It didn't do very well in the first month. It didn't recognise any text. This is obviously just one inscription. We gave it many inscriptions, but this is a representative example. By month 2, it had started learning a little bit more about where the text was, but it was still identifying sort of rough chisel marks and things as text, when that's obviously not the case. And eventually, we got to the point in month 3 with this text where it could recognise all the lines of text, but it still had problems with some chisel marks up at the top that it was recognising as text. Another example, so we have an alter here. You can see that after some further iterations, we managed to get it to recognise all the areas of text in the monument, but it was still recognising things like boundaries as upright letters, which wasn't correct. We gave it some really problematic images. For instance, this one, we obviously have areas of shadow, and that created some problems. You can see that it managed to detect text in some areas, and if I zoom in, you can see a little bit more clearly what's going on here, but it was missing out the areas in the shadow largely, and it didn't find this block of text at all. However, we did actually have some fairly promising results. We had a few more issues, such as where there was damage to a line of text, or where there was deliberate erasure of text. But by and large, we were quite encouraged, given that this was a pilot project, by the fact that it could recognise areas of text. So just to talk a little bit about some of the challenges that scene text detectors have in doing this. Obviously, the first one is inscriptions are irregular in a lot of different ways. We also find that when photographs are in any way grainy or taken from an angle that isn't straight on, so the image is slightly skewed. So for instance, if there's a monument up here and you're down here as the photographer, that can cause some problems. Obviously, there are problems with damage to the surface of the stone. You might have weathering or algae growing on the stone. And the simple problem of there being very little contrast sometimes, as we've seen, between the text and the background, so the monument surface, causes problems for a detector that's been trained on very clear and very contrasting examples of text. We also, of course, have got characters and various symbolic and decorative elements in the inscriptions that just don't exist in the original training data, so we need to do a lot more training. And we have examples like ligatures, so where letters are joined together. That also created some challenges for the scene text detector. So that was the idea behind the pilot project. We did have a go at doing some segmentation, so this was the next step. So this is where, once we'd identified the areas that contained text, we then wanted to extract the areas that contained text and then to be able to do something with them. So in this case, to be able to take some measurements. You can see that we had some results, but they needed some further work in order to be able to use them for taking measurements. The tools exist for taking measurements in images. We obviously have to have a set of absolute measurements to start with in order to then be able to take relative measurements. But you can see that things like OpenCV, which is the Open Computer Vision Library, is able to identify objects and then with bounding boxes and then take measurements between various different points. And that's where it gets interesting and useful for the kind of work that we want to do, where we're interested in taking measurements between letters and between lines and boundaries and so forth. So how could we improve these results? Well, to tackling the false negatives, so the areas of the shadows or lack of contrast, looking at improving detection of damaged areas, and looking at where beginnings and ends of lines are sometimes inaccurately given because the scene text detector thinks that the borders are letters. And we also need to improve accuracy by tackling the false positives, so things like chisel marks that aren't actually letters, and also, of course, modern inventory numbers, which appear on a lot of inscriptions. I've had a lot of issues in this with trying to get rid of the modern inventory numbers. We have plans to do a much larger scale analysis. We did apply for some funding a short time ago with colleagues at Oxford and at the Alan Turing Institute. We came very close to getting the funding, but we didn't get it this time round, but that's not to say we won't in the future. So the idea behind that is that we will improve the accuracy of the text detection with some further iterations of the scene text detector. We want to be able to locate those individual letters and then take the relative measurements between them to establish whether modules were being used. We then want to compare that to an in-person case study, because obviously we need to have secure data that we've created ourselves from a case study to compare the machine learning results to make sure that it is actually doing what we think it's doing. And then, of course, we have the possibility of analysing those results in a number of ways, so by geographical region, by time period, by monument type, and so forth. And I'm also really interested in using this to look at how different types of information is prioritised within text on monuments as well. That's a whole other question. So I guess I want to conclude just by saying I think that the pace of development of machine learning and computer vision is clearly very challenging. You know, it's one of those things where you know that you have to keep up with it, and because it's developing very quickly all the time, that takes a lot just to keep up with the pace of change in what's actually available, in what kind of tools we can use. I think that's something that is perhaps putting people off getting involved in that, and that's understandable. I think we need to commit to testing the results that we get through the use of machine learning against data sets that we've created ourselves, against experiments we've done ourselves in our subject areas, in order to make sure that we're actually doing what we think we're doing. But I've found, just through the experience of this project and also with talking with other people who are involved in this, that working within an interdisciplinary team, so working with computer scientists and data scientists who are already using these methods for other reasons, is a really productive way to start getting into this. I'm not a computer scientist, but I'm really excited to have had a chance to do this experimental project. And I actually found, to my surprise, that they were just as interested in epigraphic data as I was in the machine learning, because it turns out that the kind of problems that we have as epigraphers were valuable and useful to the computer scientists, and they sort of helped the computer scientists to develop their models in a way that they wouldn't otherwise have done if they hadn't met these data sets. So I think it's very much a two-way thing. And yes, I want to finish just by saying that I think the future of this kind of work can be genuinely collaborative if we decide that we want to take the leap into it. So thank you very much for your time.